Hello guys, welcome back to the Pioneer Academy. So in this lecture we are continuing our Newton's laws of motion. So the new topic is starting today, that's spring force. So as you know already we have learned like weight, normal reactions, tension, then motion of these masses over a pulley systems, all these things already we have learned. So now we have to learn the spring force, then pseudo force, equilibrium, and the last will be our friction. Okay, yes. So spring force we are talking. Questions will be all exactly same what you have learned already. We have to apply always FBD and we have to calculate acceleration system, tension, the strings, like here spring force you have to calculate, and same things already we have done, those things only will repeat again with the spring force. Okay, first understand this is your spring. So when spring is under natural length, means is not compressed or expansion, means it's under natural length, means it's either not compressed or also not expanded, right? Under that the spring force is not there, but when you apply a force on this, right, you apply a force like you push it, you are trying to compress this. So restoring force is developed here, that's called spring force in what? Opposite direction. Okay, and what's the value of that force? Fs is what? Minus kx. That's the value of that force, spring force, where k is a constant, is called a spring constant. Spring constant. So if you see the unit of spring constant will be k will be F by x. So it's become what? Newton per meter, right? They can ask dimension in the first chapter, unit and dimension chapter. Okay, x is called your compression or expansion. Yes. So restoring force, and minus tell you that direction of this force is always opposite to what? X. Correct? Huh? Yes. Yes. Okay. Now what we have to do mainly is this. In this chapter we will talk all the problems which are based on the steady state condition or equilibrium conditions. So all the problem we will do is based on what? A steady state, or you say what? Equilibrium condition. Okay. Yes, all problems will be like this, where you apply steady state or under equilibrium. Okay. Okay. Suppose how you write forces, that you try to understand. Suppose this spring is there, and suppose I put a block here of mass m, and I am pushing this block in this direction, right? It's attached with this block. Then suppose you want to write FBD of this, then how it looks? We have applied a force of F here. Okay. So when you cut this block, how the forces will look? No friction force is there. So this is a force applied here F. There will be a spring force in this direction, that's called Fs. Then there will be weight of this block mg and normal reaction what? Upward. These are the forces acting, right? Yes. Suppose you are expanding this, you are applying a force, pulling force on this block attached to a spring, then this force direction, that force also becomes what? Reversed. Okay. Or like here I am calling this case what? Pushing case, right? If you are pulling this system, then how the forces will look? This is your block attached to spring, mass m, you applied force like F like this one, you are expanding the spring, so your spring force will try to compress it, try to restore it. So if you add FBD of this, how it looks? It will look like that way. This is your block m, your force F here, spring force will look in that direction, Fs, and G will be downward and normal reaction will be upward. So same rules you have to follow how you write for FBDs, correct? No? Yes. Okay. Let's see these things with the help of some examples. Suppose this question is given to you, and they say that calculate acceleration of system. Questions will remain same, tension in string, and additional question came is what? The spring force or expansion or compression of the spring X, or I write here expansion of or extension in spring. Okay, so some picture let's draw like this way. There's a block placed here. This block let's call M1. This string is passing over a pulley. This is a pulley, and here we put a spring. This is a spring attached to another block what? M1. This is the case. Spring constant k will be given, or numerical value can be given to you. Okay. Yes. Now this system is moving under what? Steady state condition or equilibrium condition. We have to calculate acceleration of the system, tension in the string, and extension in the spring. Okay. Suppose this system is moving downward with acceleration a. This is moving horizontal with acceleration what? A. Okay. First step we have to calculate acceleration of the system. Same rule, acceleration is what? Net force by what? Total mass, right? Again, we are assuming there is no friction right now here, smooth surface. So this block is trying to move down, so m1g force trying it downward, then total mass is what? m1 plus m2. That's your acceleration of the system simply, right? Yes. This force not playing any role, like tension doesn't play any role because it's a string only. So the weight, this weight is going down, is making this system to move downward. This moving horizontally, so this doesn't oppose the motion. So this means only acceleration. Now, suppose you have to calculate tension in this string, this is a T. Then what is the answer? You write FBD of any block, that will be easier. So tension you want to calculate, you writing FBD of what? Suppose FBD of M1 you write. Then how, look, this is your M1. What force are acting? This is tension T and acceleration this direction what? A. So tension is simply equal to what? MA. Tension is equal to what? M1 into A. A we already calculated somewhere here. So I wrote little wrong here. It should be what? M2. This block is going. Okay. I wrote symbol wrong here. Let's call M1. This is what? M2. Okay. I wrote both M1 M2. So here becomes M2G. Now it becomes what? M1 M2 upon M1 plus M2 into what? G. That's the tension in the string, right? These questions are same only what you have done already. So new question is what? We have to find the spring force and what extension in the spring. You want to find spring force, right? Yes. So what you do? Take the FBD of the spring. Correct, no? Yes. You cut the spring as attached to this mass. Cut it from here. The spring will look like that one. This is spring, right? Okay, this is a tension T here, and here is what? Your spring force, that we call Fs. Correct? Yes. Okay, so tension will be simply equal to what? Your Fs, and Fx is simply called Kx. Suppose they are asking only the spring force, just K into X, that's your answer, okay? Yes, but generally they will ask you what? Extension. So extension will be, X will be simply tension by what? K, because this is unknown, we don't know, okay? Tension by K, tension already you have calculated here, so that gives the answer of your X, expansion the string. This is an additional question we have on this topic, that's all, okay? Yes. So we will see more example to understand these. Okay. Suppose this is given to you, let's talk about a numerical, okay? Yes. Calculate extension in springs. Okay, in simple shorthand I am writing this much only, and some system is given, suppose like this vertical we talk, there is one spring, mass, another spring, say another mass like this. You can give name, this is what? 1 kg. This is 2 kg. This is spring force of constant, let's say 100 Newton per meter. This also what? 100 Newton per meter. So you have to calculate what is extension in this spring. Let's call x1. What is extension here? x2. These we have to calculate. Okay. Yes. Okay. Procedure will be exactly same. We have to calculate acceleration of the system. Then we have to calculate. It's not accelerating because they are hanged like this one. Okay. Yes. Okay. So in this case, what you do? Directly let's write FBD of the blocks. Okay. Yes. Okay. How you write FBD? Look here. Cut this block first. You write FBD of 2 kg. Then how it looks? This is 2 kg block I am writing here. 2 kg block. Okay. What is upward downward force? Mg. Upward force is what? Directly what? The spring force here. Spring is attached to what? This block, right? So Kx, and x we calling what? X2. So you see in this case, simply your Kx2 will be equal to what? Mg. Okay. Okay. X2 will be equal to Mg by what? K. Mg we have calculated already, that's 20 Newton, and K they given us what? 100. So when you divide here, we get this much. So 0.2 meter is the extension that spring. Same way, when you want to find extension in this spring, you take FBD of that, okay? So how it looks, give attention here, I am talking about FBD of 1 kg. What will happen? This is a 1 kg block. Upward force is what? Kx1, this spring is attached. Downward force is what? Mg, and what? This spring force, that's Kx2. So in that case, Kx1 will be equal to what? Mg plus Kx2. Kx1, Mg is what? 1 kg means what? 10 Newton. Kx2 means what? Simply Mg, right? Mg of this block. So that become what? 20 Newton means 30 Newton. Or x1 will be equal to 30 by K, which is 100, 0.3 meter. These are the extension in these springs. So doing one more problem on this. Let's do this problem, and they're saying calculate, question remains same, all question, any question they can ask you, calculate acceleration of system, tension in string and extension of spring. Okay, similar question now. Okay, and let's say this type of picture something, there's a block 1 here, let's say it's 1 kg block passing over a pulley, and let's say spring here, then should I write spring here? Let me write here, one block here, make it more complicated, one block, then one spring attached to what, another block. Okay, 1 kg, let's say this is 2 kg, let's say 3 kg, and K is given, let's say 50 or 100 Newton per meter something. Okay, yes. So now they are asking what is the acceleration of the system, tension, the string and the extension of the spring. Again 3 questions. Okay. Also they can ask you the reaction at the pulley. I told you this force, that force you have to add. Okay, by vector rule. Okay, let's see here. First we have to calculate acceleration of the system. Let's calculate. Acceleration of system is what? A is what? Net force by what? Total mass. Net force. Who is making the system to move downward? These blocks are moving down with the acceleration A. That block moving what? Acceleration A horizontally, right? Okay. So who are making it move down? This weight and this weight. 2 plus 3, 5 kg means what? 50 Newton by total mass. 1 plus 2 plus 3 means what? 6 kg meter per second square. That's the acceleration of the system. Simple. Same procedure. Okay. Now we have to find tension in the string. You can take FBD of this, a tension T. So for tension you can take FBD of the block, right? So FBD of 1 kg when you take, how it looks. This is a block, 1 kg block, and here is tension T and accelerating this direction A. So T is simply equal to what? MA of this block. M is given 1 kg, right? Acceleration we have found 50 by 6. So tension also becomes what? 50 by 6 Newton. Done. Okay. Third equation, what is the extension in the spring? Extension in spring. Okay, so let's take FBD of what? Your choice. You can take this block also, you can take that block also, you will get the same answer. Okay. First easy is what? 3 kg I am taking. So FBD of 3 kg suppose you take, then how it looks? This is your 3 kg body and mg is what? Downward, and this is a spring force, let's call it Kx upward. Then this system is accelerating what? Downward with acceleration what? A. Clear? Okay, clear. So let's write. So what will happen? So let's write mg minus Kx is equal to what? Ma. This is the equation? Yes. mg means what? 30 Newton minus Kx is equal to ma. 3 into A we have calculated, which is what? 50 by 6. So 6 go through this become what? 25 Newton. So Kx should be equal to 30 minus 25 means 5 Newton. Or x we have to calculate, which is 5 by K. K already we know is what? 50. Right. So it goes here and 0.1 meter. That's the extension in the spring. I said that the same answer should get if you take FBD of that block also 2 kg. Let's try it. Suppose you take FBD of 2 kg block, then how it looks? This is your 2 kg block. Okay, and then tension T upward in the string, then mg downward, then spring force Kx also downward. How you writing spring force? Like expanding, so spring force will be that direction, right? Right? Yes, compressing. So when you cut this body, it should be downward. When you cut that body, it should be what? Upward. Okay. And accelerating A what? Downward. So it means what? What is the equation here? Mg plus Kx minus tension T is equal to what? Ma. Mg we know 2 kg means what? 20 Newton plus Kx. Tension we have calculated already. Where? Here. 50 by 6 is equal to Ma. 2 into acceleration we have calculated somewhere. Where is acceleration? That one only, 50 by 6. Okay. Okay. So 20 plus Kx. This term goes that side. So it becomes 3 times of 150 by 6 means becomes what? 25. Or Kx becomes what again? 5 Newton. So x becomes what? 5 by k. K is again given what? 50. So again we are getting 0.1 meter. Same answer we got already here, right? So nothing is new in spring forces. All rule and procedure will remain same. You have to write FBD, you have to calculate acceleration of the system. Okay, spring force came just like writing tension in string. Same here writing what? Spring force, right? direction like this, you are expanding, it's like that way. So when you write for this block, the spring force will be upward. When you write for that block, spring force will be downward, right? So these directions you have to write carefully, that's all. Okay. So this was the spring force. Now you have to talk about pseudo force. Okay, now we are talking about the next part, pseudo force. Okay, yes. So first, what's the meaning of this and why we need this force? So this force is called like an imaginary or a corrective type of force. Okay, this is used to explain the motion of a body. Actually what happens, like we have two type of frame of reference in which we do apply our laws. One is called like inertial frame of reference, and one is called non-inertial. Inertial means where we can apply laws of inertia, right, means Newton's laws, and non-inertial where we cannot apply. So in this type of force says you cannot apply like your Newton's third law also, like action and reaction. Action will be there but reaction will not be there. Okay. And so I said once more, it's just an imaginary or what corrective type of force. Okay, yes. So how it looks, suppose okay, what is formula of this force? Same only, F is equal to what? Ma. Okay, yes. Now listen how it looks. Suppose you are in a truck, there's a truck or bus, okay, and you have hanged a pendulum here. Supposing this is a pendulum. Okay, yes, it's a pendulum you hang from the ceiling of what, this bus or truck. And I said case 1, this bus is at rest. Okay, at rest. When bus is not moving or at rest, okay, it will look like this. The pendulum will hang straight from this, right? This will be the situation. But if the bus is accelerating, bus is what? Accelerating. Suppose same bus start accelerating this direction. In this direction bus start what? Accelerating with acceleration A. Then what will happen now in this case, right? The pendulum will not look like this one, right? Yeah, imagine this, it will move little what backward like that way, right? Pendulum will come here. This should be the real position, but it will not be here, it will come what here, that's some angle theta. It will make an angle of theta with what? Vertical, right? Why this happens? Because of what? This pseudo force. So if in this situation there is only one force, what? mg, acting straight downward. But here we have two force. mg was there already, correct, here, plus this body, this system is accelerating that direction, so force will be what? In opposite direction. So another force comes here, that's called pseudo force, that way ma, correct. So this one force is here and one force is here. When you take vector sum of these two, it comes this a net force, let's call it F. So how much that we can calculate? One force is weight straight downward, one force due to what? The acceleration of the system, that's called pseudo force, ma in this direction. Okay, so what is net force here? In this case, net force on this pendulum will be, there are two force, this force and this force, and how they are acting? Perpendicular. This angle is what? 90 degree, right? So vector sum, when you write net force, it will be root a square b square plus 2ab cos theta. Cos 90 means what? 0 that time. So a square b square means becomes simply ma square plus what? mg square. Correct. So it becomes simply m root of a square plus what? G square. That's a net force, right, on this block. So they can ask you net force, and then they can ask you that what is the angle made by this pendulum with vertical theta, they can ask you. So in this picture we see tan theta is simply equal to what? This side by that side, right, perpendicular by base, which is what? ma force by what? mg force, or a by what? g. So tan theta is equal to a by g, or theta is equal to tan inverse of what? A by g. Correct. Pseudo force. Okay, let's see some more example to understand. Suppose this type of question is asked like so what horizontal acceleration should be given to wedge so that blocks remains stationary or at rest, okay, with respect to wedge. Let me draw a picture to understand this question. Suppose this some wedge is given to you, this type of, this angle given theta, and you put a block on this. So they said we want to keep this block stationary of mass m, then what horizontal acceleration we should give to what? This wedge, correct. If you want to keep that stationary, you should move horizontal, this block, this wedge in that direction, so that pseudo force on act in what? In opposite direction and remain stationary. Let's write forces. This force is what your mg, correct? That is called what? Mg sin theta. This is called what? Mg cos theta, correct? Because this angle also what? Theta we know, okay? This we learn in friction chapter, why that angle is theta, okay? Yes. Okay, then I am saying now ma force, this system is accelerating that direction, so pseudo force will act what? In this direction, just opposite, ma. Then we know that you want this component of ma, that angle theta, that angle also what? Theta, correct? No? Alternate angle. So this component become ma cos theta. So for this to remain stationary in this direction along the incline, we have two forces, mg sin theta and ma cos theta. So for the block to remain stationary, we should write that mg cos, sorry, not mg, ma cos theta should be equal to mg sin theta, right? Okay, so goes here. So what should be the acceleration? A should be equal to g into sin theta by what? Cos theta, or a should be equal to what? G tan theta. Yes, this the acceleration should provide horizontally to this wedge so that this block does not slide down, correct? Okay, or let's do it opposite of this. We want to make this fall freely, correct? Na? We want to slide down, then you should give acceleration to this block in that direction, right? This way, so that they fall down. Opposite question of this, what acceleration should be given to what? Wedge, so that the blocks falls freely. Yes, so in this case, same picture I draw. This angle is theta, this is the block here of mass m. We should give acceleration to this block in that direction if you want to make it fall down. If you want to keep it stationary, you should give in that direction, okay? Yes. Okay, let's write. So now let's write, this is what your mg, again same thing, mg sin theta, this is what your mg cos theta, right? Yes, that's your normal reaction. And now ma force will be here. This wedge is accelerating that direction, so pseudo force on this block will be in opposite direction, ma, correct? Okay, same things we have to do now again. So we have tried now what is the component ma along that direction and along this direction, okay? Yes. So if you see carefully, we know that this angle is theta, that angle also what? Theta, right? Okay? Yes. So component of this will be along that direction, will be how much? Upward direction, that I should write as ma sin theta, right? This will be ma sin theta, correct? Now let's equate them. N plus ma sin theta should be equal to mg cos theta. For this block want to leave the surface, then normal reaction should be what? 0. When a body is leaving a surface, always normal reaction becomes what? 0. So let's make that term 0. Then ma sin theta should be equal to mg cos theta. Goes here, then acceleration should be equal to what? G by cos theta by what? Sin theta. A should be equal to G by what? Tan theta. This answer is just opposite of that answer if you watch carefully, right? Okay, this was all about what? Our pseudo force. Okay, we are talking about what? Translational equilibriums, okay? And so already we know, many times we wrote that for equilibrium the net force acting on that body should be what? 0. So already we know that the sum of all forces acting on that body is 0, then it's called what? Equilibrium. Multiple forces are acting, you can write in many form, like if you want to write vector form, then how you say that? In vector form how you write? You should write like that, the sum of all forces, like vector force F1 plus F2 plus F3, it goes on, should be equal to what? Always 0, right? Now sum of all forces should be equal to 0, that's called, then the body will be in translator equilibrium. So here we have to talk two things, mainly here we talk about Lamin's theorem, which we apply for 3 forces, or you can some conditions given where like some forces are unknown and they are talking about translator equilibrium, then you can write the component x direction, y direction, that's called Cartesian component, and you equate them to 0. Means how you should write? Like in Cartesian form, that sum of all force in x direction should be 0, sum of all force in y direction should be also 0, sum of force in z direction should be also 0, right? These conditions you have to write and you find your unknown force, right? Okay. But mainly here we have to talk about what? Lamin's theorem. Lamin's theorem, okay. So this we apply for 3 forces. How many forces? 3 forces. and they should be what? Under equilibrium. When three forces are given, and generally if you know angle between the forces, then you can use Laminar's theorem. Okay, to write vector component also we need angle only anyway. Okay, so if you have three forces, suppose these are three forces acting at different angle. So let's give some names: F1, F2, and what? F3. Right? So you call this angle as alpha, that angle as beta, and that angle was gamma. Then what is Laminar's theorem says that the force, the ratio of the force by sine of opposite angle is always equal for all three forces. It means what? This force F1 by sine of opposite angle, which is what? This angle, right? Yes, that's called sine alpha. It should be equal to what? That force F2 sine of opposite angle, which is what? Sine beta here, is equal to what? The third force F3 should be equal to sine of what? Gamma, right? So here we can find the unknown force or unknown angle between the forces using Laminar's theorem. Okay, yes. So Laminar's theorem is applicable up to what? Three forces only, for three forces, not two forces, not four forces, just three forces. If you have two forces or four forces, you can write vector rules. Okay, yes, you write the component x directions, you write component y direction of all forces, and they take their sum and it should equate to what? 0, to find what? Some unknown. Okay, let's see example on Laminar's theorem, which is little important for us. For example, calculate tension in strings which are given as T1, T2, and what? Suppose T3. Suppose this question is given like there are three strings and they are attached to what? Some ceiling. This angle is say 30 degree, that angle says 60 degree, and some weight is hanged here. Right, let's say it's what? 10 kg. Right, so you have to find what is tension in this string T1, what is tension in this string T2, and what is tension in this string T3 using Laminar's theorem. You can write vector component also, we'll do by both method. Let's see. So here you see three forces are there. Okay, T1, T2, and T3. T3 is nothing but what? Weight of this block itself, right? Because they are not moving, you write FBD of this block, then mg is equal to what? T3. So T3 is directly we know how much is simply what? 10 mg means what? Mg, or you say what? 100 Newton. Done. We have to find T1 and T2, correct? Okay, so we have to find angles here. What are these all angles? So let's draw a horizontal line here. Then you see this is 60 degree, that also what? 60 degree. This is what? Your 90 degree, right? Alternate angle, this and this one. Okay, that's 30 degree, that also becomes what? 30 degree. So this becomes what? 90 degree. Horizontal line is a vertical line. Okay, so if you watch carefully that what is this angle, we need to calculate that angle. So this angle we know, that angle we know, right? Yes, so that angle, give some name, that theta. How much that angle first? Okay, 360 minus these two angles, this angle and that angle. So this becomes minus 150 and that becomes what? Minus what? 120. So 360 minus 150 means what? This becomes 270, correct now? Yes. So 360 minus 270, how much? So 60 plus 30 means what? 90 degree. So that angle coming what? 90 degree. Like this you have to find all the angle using geometry simply. Okay, now we write Laminar's theorem. Write any force like T1 force, T1 by sine of opposite angle, sine of means what? Sine 90 plus 60 is equal to, you can write any known force, like here T3 is known, okay, this force. So T3 how much known? 100 by sine of opposite angle, which is what? Sine simply 90, correct? Okay, so T1 is only unknown, you can find sine 90 becomes 1, T1, this is what? 90 plus 60 means become cos 60 is equal to what? Simply 100. So T1 is what? 100 into what? Cos 60. Cos 60 means what? 1 by 2. So this become what? 15 Newton. Right? Same way you can find T2 also. Let's write for T2. So T2 by sine of opposite angle. This is the opposite angle. 30 plus 90. So it becomes sine 90 plus 30, that's a sine, is equal to some known force. You can write anyone, this is known, that unknown, this is easier, okay, which is what? 100 Newton by sine what? 90, right? So this also becomes, now how it becomes? T2 by sine 90 plus 30 means what? Cos 30 is equal to what? 100. T2 is equal to what? 100 into cos 30. Cos 30 is called root 3 by 2. Okay, root 3 by 2. So 50 into root 3 Newton. That's the answer, right? So using Laminar's theorem, you can find the unknown forces if you know angles between these forces, because rule says that any force by sine of opposite angle is always equal, right? Yes, for all forces. Okay, suppose another question we'll talk here. Let's see one more question here. So suppose again same question, calculate tension in the strings. Okay, calculate tension in the strings. Okay, and some situation is given like this way. There is a block which is held by two string like that way. Okay, say this is what 10 kg again, simple. Okay, what is tension in the string T1, what is tension in the string T2, and let's say what angle, this angle is suppose given to you what 60 degree, only this angle is given and we have to calculate tension in the strings. So again we have three forces here, this T1, T2 and what one force you can write the strings that T3. So first you see T3 will be equal to what mg only, right? That's simple, T3 will be equal to mg, that's what become 100 Newton, done. Now you have to calculate all angles. So let's draw geometry here and draw all the angles. This is 60 degree, that becomes what 60 degree, this is 90 degree, that's already 90 degree. So this is a remaining angle, how much? So 360, that theta will be how much? 360 minus these angles. So 90 minus 90 minus 60. This become 180, 180 minus 60 means what? 120 degree. So that angle is what? 120 degree. Using geometry you have to calculate all the angles, okay? Now write our Lamin theorem. So any force like T1 by sine of opposite angle, this is T1, this is the angle, that becomes sine 90 plus 60 is equal to any non-force, this is a non-force, so 100 Newton by sine of what? 120. 120 you can, if you want to write, you can write like sine 90 plus 30, right? Yes. Okay, so T1 by sine 90 plus 60 means what? It become cos 60 is equal to 100, sine 90 plus 30 means what? Again cos 30. Our T1 is equal to what? 100 by cos 30 into what? Cos 60. Okay, 100. Cos 60 means what? Simply 1 by 2, and cos 30 means what? Root 3 by what? 2. This get cancelled. So we are getting answer 100 by root 3 Newton. Correct? Same way you have to calculate T2. T2 by sine of opposite angle, that's what? Sine 90 simply is equal to this force which is what? 100 and sine of what? Again 120 means 90 plus what? 30, right? So this become T2 is equal to 100 sine 90 plus 30 means cos 30, cos 30 means what? Simply root 3 by 2. So this should be what? 200 by root 3 Newton. These are the answer. So now what I am saying that if three forces are there and angles are known to you like this way, you can use Lamin's theorem to find the answer. But if you more than three forces are there, then what you do? You can write vector sum. Means what you will do? Same thing only. You write the component like T1 along that direction. So this component becomes like T1 cos 30, right? Then that component becomes what? T2 cos 60. Component this along this direction also become T1 sin what? 30, right? So this direction forces minus, right, is equal to what? 0. This minus that is equal to 0, because the forces in x direction should be 0, y direction should be 0, and z direction also should be 0. So you can write vector component also and equate them to 0 to get the unknown answer, right? Or three forces you can write what? Lamin's theorem, okay? Yeah, so here we finish all the type of forces, leaving what? Friction force, okay? So friction force we writing because a little big and important, so we are doing a separate topic for that, separate series of lecture, okay? Yes, okay, thank you.